When it gets warm out, I like to throw a few extra ice cubes into my water. But that got me thinking, how are ice cubes made anyway? Well, I can pour liquid water into a mold, which then cools in my freezer, resulting in solidification of the water. Then the ice melts in my water, making it cool again. Converting a material from one state to another is a pretty useful trick to help cool off in the heat. But can we use it in a broader sense within engineering? Unlike water, engineering materials are not liquid at room temperature, so rather than removing heat to cause solidification, we'll need to heat up material in order to convert it to a liquid. Perhaps this liquid could be manipulated and allowed to cool and solidify into a new shape. And maybe we could make use of this to manufacture complex parts. Let's go to our hypothesis board and design an experiment to investigate further. Based on my own experiences with making ice from liquid water, it seems it should be possible to melt a material, pour it into a mold, and allow it to solidify to form a new part. Therefore, I will make the following hypothesis. A solid material can be changed from one shape to another by transforming it into a liquid state, pouring it into a mold, and allowing it to solidify. This process will only affect the shape of the material. As you can see, this hypothesis has two parts: that we can change the shape of the material, and that it changes only the shape. We'll need to be aware of this when designing our experiment, since we will want to look at both parts of this hypothesis. Now let's think about designing an experiment for our hypothesis. We could take a solid material and attempt to reshape it by melting it, pouring it into a mold, and allowing it to cool. To evaluate the first half of our hypothesis, we can look at the final shape of the solidified part and see how effective the process was. The second half of the hypothesis requires a bit more investigation. We hypothesized that only the shape would be affected by this process, so we should find a way to compare the state of the material before and after it goes through this process. We could do this by comparing any number of material properties such as stiffness or strength, or even just by the visual appearance of the material. For our experiment, we will compare the appearance of the material both on its outer surface and inside the material after we break it open. Now that we have a concept for our test, let's see if we can carry it out using some basic supplies that you might have at home. For our experiment, we're going to use chocolate, my favorite. I happen to have chocolate chunks like you see here, but you could also use another form of chocolate, such as a chocolate bar or chocolate chips, just so long as it's plain chocolate. I also have a silicone mold to provide the chocolate's final shape. First, we'll need to melt the chocolate. Here, we have used a silicone cup to melt the chocolate in a microwave oven. But be careful, it's possible to burn chocolate, so we're using short bursts in the microwave, checking between each burst to see if the chocolate has melted. Now that the chocolate has melted, we can pour it into the mold and leave it to cool and solidify. Now that it's been a couple hours, let's take a look at the result of our experiment. Taking the chocolate out of the mold, we can see that it has indeed retained the shape of the mold. This first part of our hypothesis has been confirmed. But is the material actually the same? Let's break open a couple of our molded chocolates and a couple of the chocolate chunks used to make them and compare. In the first comparison, the molded chocolate and original chocolate chunk look the same inside. They are both dense, solid pieces of chocolate. However, in our second comparison, we can see some interesting features in the molded chocolate. In the molded chocolate, there appears to be an air bubble or void in the material. Additionally, there also appears to be a small piece of foreign material in the molded chocolate. It appears something has contaminated our chocolate, perhaps due to the mold not being entirely clean when the chocolate was poured into it. So now what can we conclude from our experiment? The first part of our hypothesis was proved correct. We demonstrated that a material can be reshaped by melting it using a mold to form a new shape. In engineering, this process is known as casting, and it's used to form many different structures, from simple toy building blocks to complex engine components. It's quite a convenient process for making complicated structural shapes. But we also demonstrated that sometimes the casting process influences more than just the final shape. Hence, the second half of our hypothesis is not always true. We observed that material defects such as voids can form in the material and that foreign objects can contaminate the material. Engineers try to manage these risks through careful design of the molds and careful control over the casting process. Perhaps one day you can apply your newfound know-how to design a complex casted structure.